So, hello everyone. My name is Fabio Niephaus, and I'm a second year PhD student in the software architecture group at the Hasso Plattner Institute, led by Professor Dr. Robert Hirschfeld. And I'm here to talk about polyglot notebooks with Squeak Smalltalk on the GraalVM. Before I start, I'd like to thank Oracle Labs for sponsoring this work. And let's see what we got here. So the state-of-the-art programming, most of the people I hope here in this room will agree, still looks like this. Most applications, they're written in a single language. And this language decision is not even made by me sometimes. Maybe other people have requirements. Maybe there's different use cases, different skill sets, or management. And we as a software developer, we're constrained by this language decision. We're limited by the frameworks and libraries that we can use, and the tools, of course. And as a consequence, lots of developers have recreated a whole bunch of libraries and frameworks across all languages that we got out there, which are a lot. And I think that's a bad thing. Well, of course, we want to integrate with other languages, right? So there are these two mechanisms which have become very popular, foreign function interfaces, so you can call out to subroutines written in a different language. Or in a process communication, so you go through some shared memory, or you do RPC calls over the network. But both of them, they use different abstraction layers, and they both break our object-oriented paradigm and our tools, in fact. So you can't debug through an FFI call, at least not if you haven't put a lot of work into it. So all of this and keeping all of this in sync and making it work is a lot of work. So I asked myself, can we do better? And how can we integrate with other languages, right? And that's where I'd like to introduce you to GraalVM, the one VM to rule them all. Well, actually, that's the name of a paper, a very early research paper on GraalVM. And I encourage you to have a look if you want to know how this virtual machine actually works. So it's just a screenshot of the website. But what's important here, it's a high-performant polyglot virtual machine. Okay? If you have a look at their website, they're supporting a whole bunch of languages already. And I worked on something that brings Smalltalk into the equation. So before I start with a demo, I'd like to show you what the technology stack actually looks like, because GraalVM is not just one VM. There's a lot of components that you can work with. So here's just a little overview of what that actually means. GraalVM is actually a JVM on the very bottom with a different compiler, the Graal compiler. And on top, there's this language implementation framework called Truffle, which is designed for implementing high-efficient AST interpreters. And on top, there are the languages. And GraalSqueak is now one of them. And compared to all other languages, I don't have to tell you, because this is this part of the Smalltalk community. We also have a programming environment, which is unique. And yeah, and there's a whole bunch of problems that come up if you want to try and do something like that. If you want to be fully compatible with a Squeak image, for instance, you need to be compatible with the bytecode set. But like I said, Truffle, AST interpreter framework, so you have to make that work, right? So we put a lot of work into GraalSqueak. We built the VM basically from scratch, implemented a bytecode loop, implemented primitives, plugins like Balloon and BitBlit and all that stuff, and make it all work on the GraalVM. And that's what I like to show you now, and what that all looks like, and how we can use that to build polyglot notebooks. Okay, so let me fire up my ESUG demo image on GraalVM. And what you see here is a normal Smalltalk workspace. Right? What I can do, though, is I can evaluate code from other languages. The very first time I'm doing this takes a second, or maybe a few more, to load the whole Python standard library into my object memory, right? So the next time I'm doing this again, it's much faster. So let's evaluate JavaScript and go for the math library, right? So what's that? It's a foreign object. Well, it's a non-Smalltalk object. So everything that's not a Smalltalk object, it's been displayed as a foreign object. But I know I can do math min something, right, and get a result. This is JavaScript code, so I'm not going to run it here. But I can send a min message. And let me put in my Smalltalk 9 and my Python 7. Right? So I'm sticking the languages together. And when I run it, I get the 7. For the curious, this doesn't really matter. It just sends min, right? So I can just put whatever I want. This is part of the trade-offs that you have to make. But what's also cool is I can change the base language of my workspace. This is a Squeak Smalltalk workspace. Let me put this into JavaScript mode. And now I can evaluate. Oh, I just copied everything. Oh, shortcuts. Oh, I think I messed up. Yeah. I don't need you right now. Okay. JavaScript workspace now. I can evaluate this guy. And let's do something fun. All languages know about this bindings object. So it's a special object which I use for sharing between all languages, right? So I'm in Smalltalk mode. Let me put something into this. Call that M. Bouncing atoms morph. So this just put a new bouncing atom morph instance into this magic bindings object. And it should show up in here. And in fact, in the Explorer, I can get a little preview of what that actually looks like. But when I switch the base language, let's say we go to Python. Now I have to evaluate Python code, right? So I'm not going to run the first line. But I can send a message from Python, Smalltalk message, to that Smalltalk object, right? So open in hand gives me that morph, right? Or in fact, in JavaScript, I can abandon the guy. And it's gone. Cool. There's more. You've seen the inspector tool. So let's just say I'm evaluating an empty Python list. So now I can actually look inside this Python object as if it was a Smalltalk object. So I see, oh, these are all magic things that the Python environment uses, but there's also this public interface, right? So since it's a list, I can do append. Let me put in 42. So the return of this append returns a none in Python, which is displayed as a foreign nil, right? And you also saw that the representation just updated. So this foreign object is array-like. It has a size of 1 because I just put the 42 in. And it has 50 members, which are all displayed on the left. So, and I get this live object tooling for free because that's already been worked on in Squeak. And I can just use that for all other languages. So on the bottom, in fact, there should be the 1, and that's the 42, right? So I can play around with this. So now that I've showed you our Polyglot workspace, some of you might be familiar with notebooks, with Jupyter notebooks. On the web, very popular in the data analysis community. And but they're limited. Usually, in a normal Jupyter notebook, you can only use one programming language. And I just want to give you an example of what it could look like if we had a notebook system in Smalltalk. So as an example, there's this contributors web page for a conference called Programming, which happened this year. And what I want to do is I want to analyze how many contributors per country this conference has. And I can derive that from this table with 277 data points. But what we can see is there's this the third column has the country in it, but some people, some contributors, they don't have that filled out, but sometimes we could derive it from their affiliation, right? So the idea is to always use the right tool for the job. So what I'm doing now is I'm opening my Polyglot Notebook system. It takes a second because right now it's loading Ruby. The notebook system provides syntax highlighting, and that's done by Ruby because I didn't want to implement syntax highlighting in Smalltalk. Why not just reuse something from a different environment, right? So I can add cells here on the left. Markdown is the text variant, but I can switch the language and evaluate code like Smalltalk code. Can run that. And then I get a little an Explorer on the bottom, right? So this is much cooler than the print stuff that you get in normal notebooks. On the right, there's already an Explorer opened on this bindings object, so we can see our morph there. But this is not going to be part of this particular notebook. I'm going to preload it from a file, a Jupyter file. Actually, this is fully compatible with this format. So what you see here, oh, maybe I should move this over. So syntax highlighting works, and that's done by Ruby, actually. So the first box, I want you to have a look at the first box first. This one downloads that website that I just showed you, puts it into Nokogiri, which is a powerful Ruby parsing library, and then it gets the content out of the table, right? So when I run this, and I hope my internet connection works, it takes a second to load Nokogiri. Let's see, and we get 277 results, so, which are foreign objects. They look like arrays, and they contain foreign objects. They look like arrays again, and then there are foreign strings because Ruby strings. And if we look at that, the first guy is Rodin, and that's his entry, right? So I just grabbed the data from the web using Ruby in my Squeak environment. So in the next cell, I have access to this rows key, which is also now in this bindings object, right? Same thing. And I can use a Python library, which is called PyCountry, which simply has a list of all countries. So I can use that to filter the second column, which is the country column. So let me run that code cell. And we get 143 entries as a result. So I'm not very happy about this because out of 277 entries, I only got 143 data points now after cleaning because I didn't look into the affiliation column. So I can do or CNAME in row 1. Oh, yeah, this is because of the demo mode. So I can rerun. And now I should get a few more samples. So that's 50 more, that's good. And we looked at the table, there are some data points missing anyway. So, but what did I just got? I got a new country object, which happens to be a Python list. So I can explore the Python list and look into it and see what it can do. And on the bottom, there's the data, right? So now I've got a list with lots of countries, and that needs to be aggregated and visualized. So what machine learning people do a lot, they visualize stuff in R, right, with ggplot. So why can't I just do that? So the last cell is actually what does that. It's got this ggplot magic, which is a common thing. It just adds some boiler code in order to be able to use ggplot. So I put this countries list into a data frame object, and then I use the ggplot API to render everything. And now, since this is the first time I'm using R, same thing I told you before, it has to load the R standard library, which is big, and it needs to load ggplot and all its dependencies, which is big. But eventually, we get a result, and here's the result, right? But let's not forget. But let's not forget we're in a live environment, right? So I can just copy this guy and put it to the side, right? Whoop. And this is just one conference, and fortunately, conferences, they use the same CMS, the same content management system. So here's Splash, which is in October, 699 data points. So let me just quickly change the URL. Oh, and rerun all. Now it shouldn't take too long. 699, 436, and here we go. You can compare it. We compare. Yep. So that's the Polyglot Notebooks. Yeah, like I said, takes a while to reconnect. Like I said, everything that I've been using here was the Squeak VM, which was Squeak, which was running on GraalVM, and I can get the interoperability on object level for free. And of course, you can also do this with other languages like C. Objects can be mapped onto structs, and message sends can just be function calls. So there's a whole bunch of stuff that I just couldn't show you because there's not enough time. If you're curious about implementation details, performance benchmarks, more tools, and how we implemented those tools, have a look at the Squeak paper that just got accepted at MPLR, Managed Programming Languages and Runtimes at Splash, co-located with Splash. I'm going to present in October. And since there's an interest in Squeak, I thought it's fun to show you a few other things as well that we can do with it, right? So let me do another demo. So now I'm opening up a pretty similar image with some other code in it, code that I worked on with some of my students, some of our students, in fact. And most of you know that Squeak uses Tool Builder to build tools in Morphic. So there's this Morphic Tool Builder which takes a spec, Smalltalk spec for the tool, and builds it in Morphic. And we thought it would be fun if we could just experiment a little bit and swap out frameworks, right? And we can do this with Java. So why not build a Java tool builder and then render the same spec in Java Swing, right? So that's what this button does. It renders the Polyglot workspace that I showed you before in Java. So now I get the same experience. Right, I can evaluate code, and I haven't tried that actually. Let's see, Python for the very first time. Oh yeah, we get an inspector. That's all rendered in Swing, and I think even a workspace, even a browser should work. Browser built with Java tool builder new. Yep, here's the tool builder. Oh, something's going. Sometimes it's a little flaky, but yeah. So that was really easy to build actually in this environment because you can do interop with Java, right? So in my workspace, I can do Java type to have a look at Java classes. Let's do frame. That's the AWT frame class, and with all its constants and globals, but also the getFrames thing. So self getFrames should give me all frames. Yeah, this one doesn't know about frames, but I can still execute. So now there's 4 frames because I opened a bunch of windows, right? And they're all being drawn in frames. I know the first one is the one this environment is actually drawn in. This guy, the big guy, and I can inspect the object. So this is the frame object representing the VM. So I can look inside the VM and do stuff from here. Very powerful, but also very dangerous. Let's try this. Okay, it's in fact that window, right? And I just feel like closing this one, the image at least, using system. It's the system object. I'll just call exit on that one. Yeah. Okay, done. I had some time to play around with this here at ESUG with other people, the Queries community and Seaside, and I just wanted to show you this little video that we recorded during one of the talks. Philip and I worked on running Seaside on Squeak here at ESUG, and that's the video that I took of his computer serving the very first HTML request that works. So this should show up. Yep, that's Seaside running on Squeak. But we're not using normal sockets. This is actually running on Tomcat. So we're using a Tomcat socket to do all of this. Yeah. Okay, that's my talk. And but before I finished, I wanted to thank this community, the ESUG community, for the innovation award that we got for this work. So thank you guys a lot. And now I'm happy to take any questions that you have. Thanks.
Hi. I have a question. It's very nice that you are able to run libraries of foreign languages as well. And I wonder, sometimes libraries, they require some C part, or they use some like C, low-level libraries to implement some, I don't know, math or something else. Will it still work, or like how's this?
Yes. Well, I'm glad I don't have to work on that. Oracle Labs does all of that. GraalVM turned into an actual product, I think in April. And what they do is they interpret that C code as well on Sulong, which is the LLVM interpreter written in Truffle.
They interpret the C code?
Yes. It sounds terrible. It's great for tools. And it's actually pretty fast, faster than you might think. So the performance is usually between 0.2 and 0.3 GCC.
So this means you don't even need the C compiler to run those libraries?
No.
But you don't even need actually all the Python and Ruby and everything else. It's all already in the GraalVM.
Yes. Yes.
Okay,
I can run Rust code and Go code and C code, C++ code, everything that compiles to LLVM. Yep.
Okay. When does it go to Faro?
I don't know.
Okay. Thank you.
Well, I'm one of the Squeak contributors, and I used that for my PhD, and it was a lot of work to make it work for Squeak. So yeah, if someone wants to work on that, sure.
Thanks.
First of all, this is just amazing to me. It's mind-boggling, fantastic stuff. Is it available?
If you search for it on Google, you might find a few papers that we wrote on this, and a GitHub repository with an update from, I think, a year ago, which is the bytecode interpreter. There's a few things why we can't open source it at the moment. I haven't been able to do this in public, collaborating with Oracle Labs and a few other things, but I hope this can go open source next month.
So do you have any idea of how it compares memory-wise?
Oh yeah, definitely. So there's numbers in the paper. There's a big technical limitations section that covers all of that. So for my 50 megabyte image, it produces a 220 megabyte Java heap, which is fine because Java objects are a little bit bigger than Smalltalk objects, at least the way I represent them in the VM. But the Java GC doesn't like Smalltalk allocating so many objects. So to make that guy happy, I put in another gigabyte or 1.3 or 1.5 gigabytes to make it all run nicely. So that's 2 gigabytes for running all of this right now. My machine has 16 gigabytes, so I don't care. And if I load more languages into the address space, then for sure I need more memory. But yeah, that's certainly a problem. Yeah.
Wait,
Oh, nice. Oh,
So, do you know the work of Chris Gibble?
I don't think so.
So you should check because Chris was working on interoperability between languages.
Mm-hmm.
He was from the VUB.
Okay. I'll have a look, definitely. Here's another question.
Yes, I just realized that it's all running in the end on the JVM, right?
Yeah, on GraalVM,
Yes.
which is basically a fork out of JVM with a different compiler.
I wondered, have you seen any performance improvements compared to like
compared
Squeak or Faro when you run, for example, Smalltalk code or I
Yeah.
don't know, Python code compared to Python interpreter or something like this?
Yeah, hang on. Let me open my little UI benchmark image.
So in the end, it's using OpenJDK, right? I can see
with
that.
a different compiler, yeah.
Okay.
So what this is, it's just an image that has this bouncing atom simulation open, and the high performance mode is off, so the frame rate is not throttled. Open Smalltalk-VM reaches 58 frames per second, tops in the very first second. This guy, 80 frames per second in the very first iteration, but it will stabilize at 500 because the granulation, the measurement is taken every 2 milliseconds, and that's how fast it can get actually. But what's interesting here is eventually what you see in the background is the Graal compiler compiling Smalltalk methods.
All the time?
All the time until it stabilizes. So there's a whole section on that in the paper too. There's a very interesting things happening. So now it almost stabilized. Yeah, but it hasn't seen any user events, and it aggressively compiled. So when I move the mouse in, oh, now it's stabilized at 500, right? So let me move the mouse in. Just de-optimized a lot because it has seen code that it hasn't seen before, and it's recompiling. Same thing with when I open a menu or something like that. So that's an interesting problem for UIs. But so far, I'm not running at 500 frames per second all the time, and it's been working great.
And one more follow-up to this. So JVM supports like threads and processes. I wonder that you can use this from Smalltalk or will it
Oh yeah,
work,
of course. I can evaluate languages and other threads as well and synchronize all of them. Smalltalk is not too familiar with all this multi-threading stuff, but you can certainly just write a project that knows about Java threads and then take it from there. So what I'm running here is tiny benchmarks 10 times, and on my machine I get 4 billion bytecode sends on Open Smalltalk VM and 15 on this one, and it stopped compiling like before the first iteration. So it compiled bench fib and benchmark. There's a performance evaluation in the paper where we use Stefan Maas, Avi fastjet benchmarks.
Okay, thank you.